everybody, Kurt with Two Brothers Hobby, and we have the Mostro 700E helicopter kit on the bench. It's from Avant Helicopters. This kit released the later part of last year, and we've had a chance to put ours together and take it out and fly it and test it out. And we're going to go ahead and get you familiar with everything under the canopy. So let's go ahead and pop the canopy off and start from the nose. One thing I do want to cover as we pull the canopy off is in the front of the canopy they have these Naca inlets or intakes for air. And you'll notice this kind of unique design, this droopy tray on the front of the Mostro. And what that does is acts as an air scoop. As the air comes in, it's in line with this tray, and it shoots our airflow up over top our ESC, our motor, and then out across our servos. You'll also see that there's kind of an absence of that big cutout they usually leave on the top of a canopy to be able to allow direct air contact with the motor since it's pulling it in through the droops. So there's some aerodynamic design considerations going into the frame design itself. Starting with that tray, it actually has two functions. It acts as an air dam, of course, and then if we pull there's two set screws. I already pulled the other one out. To be able to remove our battery tray, you have to go through this process. Remove the two set screws, lift it up, it hits this tab, and that unlocks the battery tray so you can pull it out. Slide it back in, it locks into place. As you scoot a little bit forward, you'll see it pop down, put your two set screws in, and you're back in business. This tray can be used, of course, for just about anything if you've put helicopters together. One in particular, since we're using Kontronik's power systems here, you can use it as your buffer battery tray. So if you use the internal BEC, it maxes out at 6 volts. You can put a battery up here, a buffer battery, to be able to handle some of that inrush current as you're pounding your cyclic servos, your tail rotor servo, to avoid brownouts and make sure you maintain the amperage delivery without having to rely entirely on the BEC. Speaking of the ESC, this is a Jive Heli high voltage 120 plus from Kontronik. We've got it wired through an external BEC. You'll notice that on this setup I've got my wire, my one wire. This is a slave wire that goes in. Normally it's a secondary power feed to your radio system. I had that unplugged, and then on the master connection I removed the positive lead since we're powering it with an external BEC. Typically that's all you need to do. However, you need to pay attention to the wiring on a Jive. You'll notice where my BEC taps are coming from. They're coming from the high negative and not from the high positive coming from the battery series connector. And that's extremely critical. It will not initialize if you don't pull off that high negative. So you can see we're going from the negative and then off the series positive off that first connector. Then you'll initialize and be fine. And it seems simple, and in fact, if you connect an external battery pack to the radio system and try to initialize the Jive with your main batteries plugged in, that won't work either. So your options are use the internal BEC with the buffer pack if you want to have that at supplemental power there, or use external BEC and wire it this way, and then you'll initialize. And we fought that a little bit. We had to talk to Kontronik about it, and the solution was simple, but it's just one of those, it was kind of, if you don't know it, you'll really be scratching your head. We went with the Pyro 700-52, it's 520 kV motor from Kontronik. And we'll talk about it in review. We should have bumped up a little bit. Either 750, the 800 would have suited this platform better, but you'll be able to see the flight performance even with the 700 on there. The Mostro incorporates what they call their monoblock design, Avant's monoblock design. Monoblock is something that's all-encompassing. It's about having a rigid multi-stage transmission, servo tray, significant grip and mounting points for your freestanding boom. So you notice there's no boom supports here at all. So this is an oversized carbon fiber reinforced boom. There's about 6-inch difference between the rear and front forward mounting brackets. So you have really good purchase on this boom and a very rigid boom as a result. But this entire thing all incorporated together is what they call their monoblock design. It allows us to keep our gyro attached to those hard mount points without any kind of flexibility in a frame or a secondary tray or anything. Keeping that translation between aircraft movement and gyro compensation as crisp and as one-to-one as possible. So that's why they work so hard on taking advantage of this. And it also mates up with their rigid core head design. This is DFC, and we know DFC can have some problems. Low head speed wobbles, low energy retention autos, dampening vibrations that can translate down through the main shaft into the frame. Those have all been things over the years that have been, can be symptomatic of a DFC configuration. It's actually turned some guys away from DFC, and they go with a more traditional follower arm design. Avant uses the rigid core head on both their follower arm non-DFC and DFC designs, so you can take advantage of all that engineering. As a result, and you'll see in the flight footage in our review scoring as well, it didn't exhibit a lot of those problems that we've kind of grown accustomed to potentially on DFC designs. They all vary, but Speaking of our three-stage transmission, this has become more and more popular. We've seen this design show up, this design approach show up. And what it does is it alleviates that lateral force on the motor itself, eliminating the need for a carrier bearing on the bottom of your motor. So motor changes are very simple. 4 set screws here, loosen them up, and off the motor pops. You can put a new one on, make changes, change your pinion out, whatever you need to, and you're very quickly back in business. Our batteries our tray slides from aft all the way to the back. It's a nice long tray, and in fact, it'll accommodate up to 8,000 milliamp packs. So you've got some length there, and since there's nothing restricting the bottom side, you can go with some big oversized packs, get 8 12-minute run times by going with those oversized. These are 5,000s that you've got in there for reference. We use a couple 5,000s so you can see the size it's taking up. As we move down through, belt-driven tail, we do have, let's talk about our servos briefly. We're using Hi-Tech's HS 8360TH servos on our cyclic. And these are their high voltage ultra response titanium gear cyclic heli servos. They've performed extremely well so far. We'll talk about those in depth. But we did want to run those at 7.4 volts, hence we went with our external BEC, running at 7.5 with a little bit of loss. You're safe to set this at 7.5. These will support high frequency and everything you'd expect out of a hardcore cyclic servos. Matching that up with their HS 8315TH, which is their high voltage ultra speed carbonite aluminum hybrid gear train tail rotor servo, which on the Mostro mounts right there in the back end. Very easy to access and get to. It does, however, limit the tray movement, so you'd never be able to do like a rear eject tray on it. That's where the battery tray stops, just for that. We're using an AR7200BX receiver from Spectrum. That's mounted very conveniently up here on the top of our tray. Our wires, they do offer a lot of nice routing inside the Mostro for hiding your wires. In fact, you've got paths here, and it goes all the way through. They have tie wrap points all over the place to where you can actually route it inside the frame. Since we test different gear on different platforms, we routed everything external so it's easy to get to and pull off and change. But there are some nice wire pathing considerations that go through the Mostro design. That pretty much concludes everything on the front end. It is belt-driven tail, so as we go all the way down to the tail, let's take a look at that. We've got one, as I said, no supports at all on our tail. They incorporate helical cut gears in the transmission. They incorporate a belt drive on the tail, which is simple, fewer pieces if you do have a tail strike or boom strike, and you've got to put things back together. They also go with counterweighted blade grips on the tail as well to reduce some of that torque requirement on the servo. So there's very little torque requirement from your tail rotor servo. In fact, I think you could probably step down a little bit than what we normally do on our tail rotor servos from a torque perspective. But generally speaking, they're not extremely high torque anyway, so it's going to give you that really crisp, fast response on the tail end. That's pretty much the hardware design. It covers everything, and we're going to go ahead and take it out and do some test flying. Make sure you come back for part 2 where Rob and I set the Mostro down on the bench and go through the 5x5 review scoring. Our review scoring for large format helicopters is different than our standard smaller aircraft scoring. It really looks at those key aspects: assembly, compatibility, part quality, all up weight, and flight characteristics, turnaround time, which is a big thing. How quickly can you get this thing back, get a new set of batteries in it, get it back up in the air, and of course performance, range, repair costs, things like that. So make sure you tune in for part 2 for the review outcome.